Hello everyone, welcome to this video. In this video we are going to study about the fourth property on isomorphism, which says that if phi is a mapping from G to G bar, right, these are the two groups. In that case, the first group, if the first group is generated by some element A, that means it is cyclic, then the second group G bar, that is also cyclic and it is generated by phi of that element A and vice versa. So let's have a look at the proof of this result. So the proof is also very simple as the previous results. So in this case, first of all, we assume that G is generated by the element A, right? Then by the closure property, right, we have the group which is generated by phi of A would be subgroup of this G bar, right? Now this is one thing, this is for sure, so let's mark this as equation 1. Then we would say because phi is onto, then for why it is onto, because it is an isomorphism, then for any element B in G bar, there is some element A to the power k in G. Why A to the power k? Because G is generated by the element A, right? Because the G is cyclic and is generated by A, correct? So therefore we are saying because phi is onto, then for any element B in G bar, there is some element A to the power k in G, such that when we apply phi onto this A to the power k, it will give us B, right? So that means we have written, so thus we have written this B, which was the member of G bar, right? So we have written this B as equal to phi of A raised to power, we have written this phi of A raised to power k, which we can write this as phi of A whole raised to power k, using the property that we have studied previously, by property 2, right, that we have studied previously. So this thing is equal to this. So that means we have written B as some power of phi of A, and B was some element in G bar. So therefore we may write that this G bar, right, thus this B belongs to the group which is generated by phi of A, or as B was arbitrary element in G bar. So therefore thus G bar is a subgroup of phi of A. So let's mark this as equation number 2. Now if you can see from equation 1 and equation 2, we have from equation 1 and equation 2, we have G bar is equal to the subgroup which is generated by phi of A. So this proves one way of the result. Conversely, we assume that let G bar is generated by phi of A, and here we wanted to prove that G is generated from the element A, right? So this is what we wanted to prove here. Now obviously here A is the group which is generated by A is obviously present as a subgroup of G, because all the powers of A would definitely be there, as A was some element in G, right? So what we do next is, let's mark this as equation number 1. So what we do is, for any element B in G, right, for any element B in G, we have phi of B as a member of the group which is generated by phi of A. Now why this is so? It is because this G bar is the group which is generated by phi of A, and we are taking the element B from the group G bar. So when we apply phi onto it, right, we are taking some element B in G. When we apply phi onto it, phi of B is member of G bar, and G bar is generated by phi of A. So therefore this phi of B is contained in the group which is generated by phi of A. So therefore we would say, so for some integer k, we have phi of B is equal to phi of A to the power k. Why? Because it is because phi of B is contained in the group which is generated by phi of A. So phi of B is equal to phi of A raised to power k. So this is equal to phi of A to the power k, right? Now as phi is 1 to 1, why this is so? Being an isomorphism, right, it is 1 to 1. So this would give us, B is equal to A to the power k. Why? Because as phi of B is equal to phi of A to the power k, right? So that means we have written B as some power of A, right? So B belongs to the group which is generated by A, and as B was an arbitrary member, of the group G, right? Thus we can say the group G is contained in the group A. So let's mark this as equation 4. From equation 4 and from equation 3, we have, from equation 4 and 3, we have G is equal to the group which is generated by A, and this is what we wanted to prove here in this video. Well, that is it for this video. Thank you for watching.